So, hello everyone. One person said hello. Amazing. Amazing. We're in Spain, right? You people. Did I just say you people? You people, us people, we don't stop talking. And I say hello and everyone shut up. Really? Anyway, let's try that again. Hello everyone. Hello. There you go, that's much better. They said to me, you got to start at 5. Apparently there's been some technical issues and we've got to start like 5 minutes later, so we're a little bit late. I said, it's absolutely fine. We're in Spain. Everything is late, right? And I can say that because I'm Spanish. I've been living in Spain for 35 years. I actually live down the road in Malaga. Well, not literally down the road, but and as far as I know, Malaga still belongs to Spain. And that is the last political joke that I will make. Or maybe not. We don't know. Anyway, welcome to this session. And I just know this. Now on Twitter, I'm like, Hadi's making political jokes at a conference. It wouldn't be the first time. So, welcome to the session. How many of you know Kotlin? Okay, now, keep your hands up. That's your punishment. How many of you know Kotlin before it was announced at Google I/O? Okay, few less, right. We were recently just now talking to a few of people I know in the community, friends, and we're like, oh, it's been growing massively since Google I/O, and I'm like thinking, yes, we should have just kept quiet for the past 5 years and just let Google handle it. So I'm going to this session is a little bit what I call Kotlin 102, which is, I made that up myself, which is like a little bit more than what you would normally get in some of the introduction to Kotlin sessions. I'm not going to cover anything deeply diving into functional programming, which is kind of awkward as to why am I at a conference with a whole bunch of people that love functional programming and talking about Kotlin. Well, some people think that Kotlin is a functionally programming language. Other people think that it's missing some bits of Scala, so they've provided that in a library that we're not going to name or point to. But you'll see a session on that later on, so I won't get into any category theory with a K. And by the way, where did you come up with that idea of replacing the C with a K? I've never seen that before. Genius. You should go into marketing. So anyway, we'll start with a little bit. How many of you actually work with Kotlin, other than heard of it? Okay, so good. Okay, so we're going to start at the very beginning. So one of the things that Kotlin provides you is with delegation, right? So we have first class support for delegation, where you can essentially take a class and the idea that you're composing objects with other objects in a class, and normally you implement that via what you call the dependency injection, right? So you can have a property dependency injection or constructor dependency injection, where you are passing in a dependency into a class, and then you delegating the functionality to that class. So we have that in Kotlin. So you can actually pass in a delegated a class into another class, and you say, this functionality that I'm passing in the constructor is delegated via something else, meaning that you basically save on the property declaration in that class, right? You don't need to explicitly have a property. And if you're not familiar with Kotlin in terms of property and fields, we do not have fields in Kotlin. We just have properties. If you want something that's private, you declare it private. But one of the things that are less known in Kotlin is the ability to have property delegation, which means not only can I have my class delegated to something else and then invoke the methods of that class, I can also delegate properties. And this allows for certain things, such as, for instance, reusing code. I can declare some functionality and then reuse that code across multiple classes, across multiple properties of different classes. And we have a bunch of delegated properties built in. So one of these is what's called the lazy property, okay? So essentially what that does, you can navigate to it. You wouldn't be able to do this in Vim. And what you can do is, I am not subliminally trying to sell IntelliJ here. because you know that you can get it for free. But what this basically does is it's a higher order function, and we'll quickly, we'll get into the higher order functions later, but the syntax is essentially, in Kotlin we try and stick to a consistent way of declaring higher order functions. So here is a higher order function that takes no parameters and returns of type t. And what it does is essentially a lazy evaluation of a property. So the first time that it's accessed, it will then read that property. Okay? And that's built into the library. So I can essentially say lazy, so I say val lazy property by, meaning I'm delegating that functionality to a higher order function which is called lazy, and then in that lazy function I'm passing in another function, right? And that function will be called the first time when the property is accessed. Right? And what is that function? Well, in this case, it's just some very easy function that says I'm initiating late and returns some value. Now, the point here is that obviously this I can reuse across everywhere. But more importantly, this thing over here, the lazy, is already built in. So it reduces the amount of boilerplate code that you have to write each time if you want to do lazy evaluation. That's kind of known. How many people did know that? Okay, so it's not that known. But we have a few other ones in there. We have another one that's called observable, which is basically implementing the observable pattern, right? Where I say that some property is going to be observable and I can observe it at some time, and when that happens, an event is raised. And we have another interesting one which is called vetoable, right? It's like the UN Security Council. Someone always has to veto something. And what this does essentially is say, based on this condition, if that condition is true, then I will set the value of a property. If it is false, then I will not modify the value of a property. And this also is built into the standard library. So you can see that essentially what I'm doing here is saying I'm getting three parameters over here, which is the property that I'm talking about in this case, the old value and the new value, and I'm saying that if the new value starts with an S, then this is going to return true, and that means that you can set the value of this property. If it does not return a true, you cannot set the value of this property. Okay? So values of, I don't know, if you say some business logic that you would want to encapsulate in some functionality like that. So if you were to run something like this, you would see that, the first time I'm running this, I'm going to get a value. I'm setting the value, but since the value doesn't change, it's still set to string, it's then set to string, and then when the value actually starts with a S, in the case of strange, it actually sets the value of the property, okay? And if you can't see that, it doesn't matter, it's not saying much. Right. Now, these are two of the many built-in delegated properties that we have, but in Kotlin, you can also create your own delegation. And the way that you do that is essentially you create a class that has to implement two operators. So you don't have to implement any interface or anything. The mere fact that you say that this string is delegated to a class, the compiler is going to tell you that this class needs to implement the operator the operator set value and the operator get value. Right? And as you can kind of deduce from this, essentially what that is doing is two functions. One of them is doing the get, and it's asking you, it's giving you information about the property that you're talking about in question, the old value, the new value, and what you want to do. So this allows you to set your own property. And you could take this to any level you want. For instance, I was thinking the other day that I could do some kind of implementation, which wouldn't be straightforward, but of something like a cached 302 property for a server. Right? So that when I access a property, if the hash code of that property hasn't changed, it automatically returns an HTTP 302, not modified in the case 304, not modified in the case of HTTP. There's no limit to where you can take this in terms of code reuse and property delegation. Okay, so those are some things around the built-in delegated properties and the ability to create your own custom delegated properties. Now let's talk a little bit about what you guys over here, you folks like, which is you love, the obsession with functional programming. By the way, have you, what is a functional programming language? Like, seriously, this is a question. Like, what is a language, when is a language considered a functional programming language?
It's got functions in it.
It's got functions in it. What else? High order functions. Oh, people, come on, you're at a functional programming conference. Like, Maybe we should have stepped back 4 years and said, right, let's start with the keynote. What is a functional programming language? And let's agree on that. It's consultants, right? It depends who you ask. And if it's their benefit or not, they'll say it is or not. I agree with Eric Meyer's statement on this, which is anything that allows you to treat functions as first-class citizens and as building blocks. And then from there, you can take it anywhere you want. Others would say that if it has side effects, it is not. Who cares? Anyway, right, what we have here is a higher-order function, which, as I showed to you previously in Kotlin, is very simple syntax. We always follow the same thing. If you're familiar with Java, it's completely opposite of what Java would show you. And essentially, it's the parameters and then the return type. And in this case, I am taking a higher-order function that takes another function. And this is how you can write kind of like a single expression functions in Kotlin. So if the functions only have a single expression, in fact, in Kotlin, everything is an expression. So you can just write it simply like that. You don't have to have the open curly braces, the closed curly braces. You can refer to a function by name using : : Difference to JavaScript is that you have to put the : and then you call the higher order function. You can pass in lambdas here, all of these things, right? Now, one of the things that we want to look at is this ability with inline functions. So in Kotlin, obviously, if you have functions that are calling functions and all of these are calling functions in turn and all of that, the people will start to say, oh, what about the optimization? What about the performance impact that all of this has? What about the call stack, etc.? In Kotlin, we have the ability to inline functions, right? So you can explicitly say that a function will be inlined. Now, I'll remove this, and you can see here that what I'm doing is essentially saying that this function is going to be inlined, and this function itself is going to be inlined. And inline means that every time I call this function, I'm essentially doing a copy-paste of the code in the place where it's being called, right? So I don't need to now have that call stack and keep all of that data every time I'm calling this function. Now, why would you do that? When would you do that? There are certain scenarios in Kotlin where you would do that. Kotlin doesn't automatically do inlining on functions. Where it makes sense for performance reasons, inlining is done by the JVM when we're talking about Kotlin targeting the JVM. But in certain cases, you explicitly can inline functions. And in fact, if you look through the standard library, many of the functions are inlined. So in this case, I am inlining a function. If I remove this higher order function here, ignoring the error over here, you see that the compiler is complaining to me and saying that you expected performance impact of inlining this function doesn't make sense because you're not passing in a lambda. So already it's saying to you that the only time you really want to inline a function is when you're passing another lambda in. So when it's a higher order function. Otherwise, it really makes no sense. Now, sometimes I want to have two functions. So I can have, for instance, two functions over here. And this one is something that takes no parameters and returns unit. Unit is the same in Kotlin as void, except it's not the same as void, right? But there you go. It's actually an object. We have objects in JavaScript. We have objects in Kotlin. So it's like a singleton. It's a single instance. So in this case, I have two functions. And what I could do sometimes is, for some specific reasons, I can say to the compiler not to inline that specific higher order function. So I have this ability to do a no inline. Now, in what cases would it not make sense to inline, or in what cases would it would have no performance impact, or in what cases wouldn't it be possible to do inlining? The rule of thumb essentially is in Kotlin, you only inline a function when that function, the higher order function that you're passing in, is being invoked. If you're keeping a reference to that function, then there is no way really to gain any benefits from that, because the compiler needs to have a reference to that function. So it needs to create an object and reference that function. If all you're doing is essentially calling that function in another function, then you can inline it. Now, inline, apart from the ability to provide you with certain types of performance improvements, also brings about reified generics. Now, if you come from the C# world, you know that reification and type erasure exists. Well, type erasure exists on the JVM, which essentially means that you cannot query the type of a list at runtime, right? If you actually have an inline function, so if I do something like, in this case, working lists, this will give me an error because it says that you cannot do this. I don't know the type at runtime, right? But I can inline the function, and when I inline the function, what I can also do is then say that this parameter is going to be reified, which means that I can now query the value, the type of that parameter at runtime. So in certain cases, if it's not only about performance, I can also use inlining of functions to be able to provide me with reification and information about generics at runtime. Now, inlining also has an impact on how functions behave in terms of returning. So here's a function that says numbers 1 to 100, numbers for each. If the number is divisible by 5, return 0. Print hello. And I ask you, what is the output of that function? What is it going to do? Let me rephrase that. Is it going to print hello or not? No. Okay, so we got yes and no. And that, my friends, is why referendums are a bad idea. It's not going to print hello, right? Don't take that at face value. Not the hello, I mean the referendum comment. So logically, we would think, well, why not? Well, the point is that here, this is a lambda expression, right? And what it's doing is when you return, it's returning from the lambda expression, it's returning from the alpha function. It is not returning to the point here. Okay? Now, let me take this one. This is my for each. Okay? And let me remove that. And if I remove that, this definition is exactly the same as the for each. If you look at it, right, this is the for each for element in this action element, and my for each is for element in this action of that element, right? The only difference is that if I remove the inline, I cannot now use this, which means that this behavior changes and is only applicable to functions that are inlined. Okay? Now, let's take a look at this function. What does this one do? Will this one print hello or not? It will. Why? Because I'm explicitly saying to return at the lambda statement, right? So this at for each is completed based on the actual function that you are calling, right? If this was called Felipe, then it would be called Felipe, right? It would be return at Felipe. Or you can actually explicitly define labels, right? I can define a label for lambda and tell it to return at that label. Now, there's also a different way to define anonymous functions in Kotlin, which is why anonymous functions in Kotlin aren't anonymous functions, aren't lambdas, because we also have anonymous functions, which are functions that have no names, just like lambdas have no names, you know, as if that wasn't confusing. So here, this is a different behavior. Here, I'm actually calling what you call an anonymous function, right? So I have a function that has actually no name, and then I'm doing a return. In this case, what would you think would happen? Would it actually return and print hello, or would it not? I've already told you, I said the behavior is different. If you were listening, then you would know the result of this, right? And the result is that it does print, in effect, hello. So if you don't want to use this label syntax, or you don't want to do a return at each, you can use this in a different way, passing in an anonymous function. Okay? I haven't asked you any if there are any questions, but it's okay, I won't. Jokes aside, though, are there any questions?
How does crossing line affect the behavior of those high-order functions?
Oh, crossing line is a specific scenario that is when you're cross-referencing lambdas, keeping pointers to lambdas, and in certain scenarios, I believe you would be able to do that. So it's a little bit different from the no inlining, okay? So it's like a little bit, it's like a restrictive level between inline and no inline, so to speak. Okay, now Kotlin, you're all familiar with extension functions, right? Yes or no? Yes. Okay, so essentially this means that all of my idea of type hierarchy and discovery is blown out the window. No, it does not. But what I can do is do extension functions, and then I can do infix extension functions. So I can do, for example, hello is the same as hello, and that looks beautiful. And then we can create a DSL for doing behavior-driven testing, and then the world is your oyster, and you don't have to talk to your customers anymore because they write your tests for you. So we have that, right? And so that some of these higher order functions also allow you to the extension functions, a lot of these are defined as extension functions in the standard library, right? So we have, in this case, well, it's not an extension functions, but you have generic types of like apply. So nearly all of the standard library are extension functions on generics. And then they give you a series of functionalities such as with, which allows me to access properties of an instance of an object without having to prefix every property or method called with that instance of that object, okay? Now there's something else that you can do in Kotlin, which is invoke an object. Invoke an object kind of as if it were a method, right? So the way that you do that here is I have a foo class foo, which is name string, and then I have the operator fun invoke. So I overload the operator, which is called invoke, and then what that means is that I can actually invoke foo class, I can invoke the instance and pass in any parameters and get some behavior from that. Right? Why would you do something like that? Because it looks awesome when I'm doing demos. Apart from that, you can start to combine this with what we know as lambdas with receivers, right? And that's the completely new term in Kotlin because no one else has it, and I think that's probably one of the only things that nobody else has, which is the idea of lambdas with receivers, okay? So here, let's go over to higher order, and let's do a split vertical, right? And then let's go back here and do lambdas with receivers. Okay, so here you have a higher order function, right? Which is a string that takes a string, okay? In this case, what I have is a lambda with receiver. It's still a higher order function. The difference is that instead of passing a higher order function, I'm passing in an extension function. Right? So here I am passing in a function that is an extension to root handler. What does that allow me to do? Given that this lambda is an extension to a class, it then means that I can actually access properties of that class inside that lambda. Right? So if we take a look at this get over here, I have a path string and then I have an extension function to root handler. What is root handler? It's a class that has a property request and a property response. So when I over here write, get home, right? Let's delete this. This lambda is actually an extension to root handler. Since it's an extension to root handler, what do I have access to? I have access to all of the properties of that root handler, right? So I can do request query, for instance, right? If request query is empty, then do something else, right? Now what do I have access to? I have access to response, right? And I could do response contents, etc. Okay? So this is where it allows me to start to create what we famously know as DSLs in Kotlin, right? One of the ideas that we tried to do with Kotlin was to make it easy for you to create DSLs. And this facility with the lambdas with receivers combined with certain conventions that we have that you notice that I didn't pass this lambda in to as part of the brackets because I could, right? It's like Groovy. If the last function, the last parameter to a function is another function, I don't have to pass it inside the brackets. Gives way to the ability to create DSLs, right? So if you're familiar with, for example, the Groovy DSL builders, HTML builders, we can do something similar in Kotlin and the difference being that it's all statically typed, which allows you all of the benefits that you get with a statically typed language. Okay? And the invoking over here, so what happens, I said, why do I need this invoke? So the invoking over here is because now I can actually, inside this, I can also access the response, right? And then inside the response, I can access all of the properties that the response would have, such as, for example, status code, or I should be able to. Right? Now, if I try and access that, it says to me that I cannot, and then it says an IDE has an error. If only I had a good IDE to use. But the idea here is that now that I create an object of status code, I can combine that with the fact of having the ability to invoke an instance, pass in parameters, and then create a fully fledged DSL. Okay? So, now, as functional people, did I just call you functional people? Yeah. So you might be asking, does Kotlin support algebraic data types? Well, we support it like that. Any F# people here? Normally when I show that to F#, especially Andrea, my good friend that I can't see her here, she'll say, why didn't you use the pipe? Because we don't want to use the pipe. So here, what we do is basically this is the definition of algebraic. This is how you could essentially define an algebraic data type, which essentially means a closed hierarchy that you are all familiar with, right? So what this means is that anything outside of this file, I can no longer inherit from result, right? So the hierarchy of result is closed to this specific file. Now in Kotlin, by default, classes are sealed, are final. So I cannot explicitly inherit from a class. I have to use open. If I want to, in addition, seal that hierarchy, I use a sealed. Okay? And then this allows us to kind of do better return types from functions and all of these wonderful things that you're all familiar with. Okay? A lot of the things in Kotlin, and as part of the standard library, we have all of the filter maps, all of these things that, again, you are accustomed to. All of those are eagerly evaluated. We had the concept of lazy evaluation, well, we still do. We called it as stream, and then Java decided, Java 8 came out and said everything is a stream, except not in the RX way, everything is a stream. It's a stream in our way. So we renamed that to as sequence. So sequence is essentially the ability in Kotlin to take any collection of items and convert that into a lazy evaluated collection. If you cannot have a collection of items to begin with, then you can also go the full scale of using something like generate sequence, which is a higher order function, which allows me to just essentially create a lazy sequence of elements based on the evaluation of that lambda. Okay? So that is also available. And all of these, the difference is that I'm just adding as sequence. So I have all of this available as part of the standard library as well, your filters and your maps. And as you can see, they're all extension functions to collections, generic collections in Kotlin. Okay? Now, one last thing before I move on and show you a little bit around the synchronous programming and how we do that in Kotlin is type aliases. So this is, any Haskell developers here? I expected way more at this conference. Like seriously way more. I thought like the whole room was Haskell. So Haskell, this isn't the equivalent, before you ask, this isn't the equivalent of new type in Haskell. This is literally a synonym, right? So what I'm doing here is I'm introducing this concept of type alias, which I essentially say that customer name is the same as string. That means at compile time checks, at runtime, this is in fact a string. The only thing is that I'm giving it an alias to have a more semantic meaning. So here I could say that name is a customer name as opposed to name is a string. But anywhere I can pass in a string, I can pass in a customer name. Anywhere I can pass a customer name, I can pass in a string, right? Now this is actually good in certain scenarios, apart from giving new names to things, that it can help you with what we call a phase migration. If those of you are familiar with Kotlin and have been following it from day one, if you remember what we used to do during these upgrade cycles, like all of the milestones, we used to come up with a new feature. And then at some point we thought, okay, this feature isn't that great. Maybe we made a mistake, right? We're going to deprecate. And we did this in a two-phase thing, right? The first phase was, right, this feature is going to be obsolete in the next version of Kotlin, right? This is a warning. And I'm giving you a warning. In the next version, I'm going to give you a compiler error. And we normally accompany that with the ability for the IDE to be able to fix it for you, do like a global search and replace, or Alt-Enter and fix that. So we have something similar in Kotlin with providing you as well, which is the deprecated, right? So what I can do here is I can take this deprecated over here and say that this customer class is now deprecated, right? And I pass in 2 parameters to this customer class. I pass in customer is now called awesome customer and replace with awesome customer, okay? Now this one I want to actually rename to awesome customer because that's what my class wants to be. So now what I would want to do is that customer is awesome customer, right? Okay? So I'm deprecating the customer, right? And now type alias awesome customer equals customer. That should do it. Right. Okay? So, and let's just rename that to string. So what I've done here is essentially I've renamed my type in a 2-phase process. I'm not breaking the API for anyone. And I'm saying that this API is going to change because my customer is now going to be awesome customer. And when a developer uses my my API, they're going to come over this hint that says customer is deprecated, customer is now called awesome customer, and they could do Alt-Enter and replace it with awesome customer. Okay? And that's built in with this replace with functionality that you have, which is the second parameter to deprecate it. Right? So you can combine the type alias with the deprecated to make a smooth transition for your developers when they are continuously changing the API that I'm sure you never break. So all of this is completely, utterly pointless. And I just wasted 2 minutes of your life. One of the things that maybe if you've worked with Kotlin for some time or know it or hopefully have gotten a feel for in this talk is that we have tried very hard with Kotlin to be as flexible as possible in terms of how you want to do things. So we try and limit the number of keywords that we introduce to the language, right? And we use this concept of lambdas with receivers and some of the conventions of higher order functions and multi-line lambdas, all of these things to be able to create the sensation that you can enhance the language, you can add to the language using your own keywords, so to speak, but those keywords essentially are functions. And we try to follow this philosophy in everything we do. And we do this also in terms of asynchronous programming. So when people were asking initially, like, what are you going to do around asynchronous programming? Are you going to go the route of something like C#, which is async await, or are you going to do whatever? We said we're going to delegate this to libraries. And the only thing that we have changed in that aspect is that we are delegating it to libraries, and all of the asynchronous programming in Kotlin is essentially helpers in libraries, but we have introduced the concept of coroutines. And coroutines is not a new concept. It's been around since the 70s, if not earlier. And essentially, the idea is suspendable computation, right? So I have a point in time where a function is suspended, goes off in some secondary lightweight thread, and does something, and then when it returns, the compiler knows where to pick it up and do something. Under the covers, what this essentially means is that the compiler is maintaining a state machine of suspension points and knowing when to resume and when to suspend, right? And then the work of these asynchronous calls are done using lightweight threads, fibers, whatever you want to call them, okay? So just to give you an idea of the difference here, let's do a small comparison, right? So here I have threads, which is 1 to 100,000. I have 1 to 100,000 jobs. And for this, I'm doing a for each. And I'm using a thread. Now the thread, again, this is nothing new. This is essentially, again, going back to this ability to define these types of syntaxes in Kotlin. And this is just a standard library function, right? Which is just a helper to easily create a thread. And I'm going to do thread sleep for 1 second and then print a line, right? And let's run this with threads. What do you think is going to happen? I can't hear you, people. Out of memory. Good. Yes. It prints some things, but it says out of memory, unable to create new native thread, right? So now let's do exactly the same with coroutines, right? And coroutines is essentially the same syntax, so to speak. The only difference is that I'm now doing this thing called launch, which we'll get into, and I'm doing this other thing called delay, which we'll cover in a moment. And then I'm doing jobs for each, and then doing a join. Join is a similar syntax that you have in threads. What do you think this is going to do? I'll give you a hint. It's going to work, because if not, this would be a really shitty demo. It assigns where that thread is. We'll see. So, oh, well, there you go. It finished. And in fact, I can even do 1,000,000, right? And this will also work. And the idea here is that I'm trying to show you here that this really is lightweight threads. This is not creating 1,000,000 threads. This is not creating 100,000 threads. It is using the compiler, and the compiler is creating a state machine to keep track of everything that is going on. So it doesn't need the underlying OS capabilities to be able to work with coroutines, which this means that essentially we can provide you with the same experience across all of the different platforms that we provide for Kotlin, which is JVM, JavaScript, and we're working also on native. Okay? Now, what this launch is essentially, the idea behind coroutines is that if you're used to asynchronous programming, how many of you here do asynchronous programming? Right. How many of you do JavaScript? First of all, as I always say, my condolences. Second of all, you probably are doing something where you started at some point in your life to do callbacks, right? And then you said, no, kill me now, because I do not want a tilted Christmas tree in my code, and this is really horrible, so I'm going to use promises. And then someone came and said, no, promises aren't that good, because we should call them commitments. And that was like the hipster of like, no, I want to reinvent. Because that's what happens in the JavaScript world, right? It's like, oh, I don't like this little bit. Let me just reinvent the wheel again. But the point is that you work with promises, you work with whatever you have in on the Java side. In C# you do async await, and then there is this thing called Rx. How many of you use Rx? Reactive extensions, which is awesome. And one of the things that reactive extensions brought to the table was the ability for you to work the same way independently of what platform you're on. Initially, this wasn't the case, right? Because reactive extensions came from C# and nobody took notice of it until Netflix started to use it. And they ported it over to Java, Rx Java, and then Rx Java became Rx JavaScript, and Rx Kotlin, and Rx Clojure, and Rx everything else. And the good thing is, for us as developers, it provides a uniform experience. No matter where we are, we use the same paradigm. Coroutines tries to do that, except it doesn't put you in the shift mode of Rx. It keeps you in the mode of how you're used to working, which is with imperative, top-down, synchronous code, right? When you switch to Rx, the first time you encounter Rx, what do they say to you? Oh, think of everything as a stream, and it's observable. And you're kind of like, ¿qué? And as they said in Faulty Towers, don't mind him, he's from Barcelona. But that's literal from Faulty Towers. That's Manuel. Anyway, so, you have a mind shift. Everything is Rx, but I have to go from this idea of top-down to pipeline of functions, and sometimes that pipelining doesn't work, and I got to shift back into synchronous mode with some helpers of Rx to join things and do some other things, right? And that is beautiful, and as functional developers, you probably love that, right? The whole concept of pipelining functions until functional programming really takes off, and in 10 years, we're going to have the shittiest enterprise functional code ever, right? Because someone said, I will start at the very top of the file and I'll pipeline all the way down. And so it is familiar to you, but it also introduces its issues. And what we try to do with Kotlin is move back to this paradigm of, look, why don't you just launch things in an imperative approach, and we will deal with the underlying asynchronicity of it, right? So what this means is that, let's say, for example, I take this code over here, right? And I say, measure time in milliseconds. Now, this has got nothing to do with coroutines. Nothing. That's just a helper. That's part of the standard library. Do you know what it does? It measures times in milliseconds. And I have function 1 and I have function 2, right? And function 1 is a function that delays for 1 second, returns 15, and function 2 delays 1 second and returns 27. And I'll say result 1 plus 2, total time. How long do you think that's going to take? 2 seconds? 1 second, yes. No, it takes 2 seconds, right? Because the idea is that you don't have this mind shift of asynchronicity. The idea is that this long running process will run and this one will run and it's going to run in a fiber, it's going to run any way you want, but you're still in this top-down behavior, right? Otherwise, everything I said would go out the window, right? So this is going to actually take 2 seconds. Now, we can provide you with this asynchronous model. We can provide you with this concurrency. The difference is we do not do it as keywords. As I said, we don't do it like this sync await keyword that C# provides you. We do it with a sync await functions. So here, this now is concurrent, right? So if I run this, how long do you think it's going to take? 1 second. I'm making this really easy, people, right? So it's 1 second, right? Because this is running in a synchronous mode. And then it's saying to you, here, await for the result. What is this common pool that Paco also asked me about? Similar to Rx, you can control where these fibers, these things are created. And the common pool is, as the name depicts, a common pool. But you can have different types of pools. These are called the dispatchers. So I can have unconfined, meaning I can run a little bit here, a little bit there. I can have a common pool, which is the default common pool that is being used. I can have my own custom thread context, meaning that I confine everything to a specific thread context that I'm going to be using, right? And coroutine context means that I can actually launch one coroutine inside another coroutine. So it says take the coroutine context of the parent. But even with this concurrent approach, there's another parameter to async and to launch and all of these things, right? And the second parameter is the actual start, right? And the start, what that is saying to you how I want to start this coroutine. So I can in fact take the same concept that I had in the previous example and pass in a new parameter which is saying lazy, meaning that I will only start this coroutine in a lazy way, which equates to I will not start this coroutine until I actually need it. Okay? So, given this, how long do you think this one will take? Who says 1? 2 seconds. Right? Why does it take 2 seconds? Because I only need it here. So await 1, this coroutine will only actually launch when await is called. And then once that's finished, the second await is called. And that's why it will take 2 seconds. Okay? And then we take this concept of coroutines even further. We provide, out of the standard library, we provide channels, we provide pipelines, which means basically the essential idea of streaming continuous values and the other end, having consumers and producers. We provide them actors as part of the coroutines standard library. And I keep saying standard library, but this is not part of the Kotlin standard library. This is part of the coroutines library that is available on GitHub under the organization Kotlin X. Okay? So it allows you to do a whole bunch of things. And in all of these things that we've done, we've essentially added one keyword to the language. Wow, I just found the bug in. I just found the bug in IntelliJ. There's only one, right? This parameter here, which is suspend, this is the only keyword that we've added, which means this is a suspension point, right? And this is the only place in Kotlin, thank whoever it is you believe in, that has implicits, right? There is no other support for implicits in Kotlin. So only in the case of passing in a suspend is where you have implicits, so that it makes it much easier and nicer to work with when you're working with coroutines, right? And this async and the first example that we saw in terms of launch, all this is the idea that it's taking you from the sequential world to the coroutine world. So you don't actually need to use launch. You can write your own way to launch a coroutine, but we're providing this for you. Okay? And that, I believe, is all I have time for. I hope that this gives you a little bit more overview of what we offer in Kotlin outside of the introduction. Thank you very much.